Okay. So, so it's not that the time would be 45, is that the amount would be half. So if I start off with 8,160, after 90 years, we should end up with half of that, which is 4,080 grams. That's the idea of half-life. It drops in half given the amount of time, in this case, 90 years. So when we set up the equation, we have pretty much everything we need. We have the final value. That's a little too big. We have the final value, we have the initial value, and we have the time given. What we don't have is the R, and that's what we're looking for. We need to figure out what that R value is. And if we know what the R value is, we can rewrite the equation and use a final time t is equal to 270. Okay, so the first thing we're going to do is set this up. We're going to say 4,080 is equal to 8,160. This is my final. This is my initial. E to the R, we do not know what the R is, and the time given is 90 years. So after 90 years, it makes this into half. It makes that into half. So one of the things why we use logs is that it helps us solve for exponents. As you guys can see here, the exponent is what I don't know. I don't know what the exponent is. And to solve for exponents, we need to use logs. So let's go ahead and move values over as we can. I'm going to move this over to clean it up. And you should realize it gives us 480 divided by 8160 is 1/2, right? And the idea is this multiplier here gives us half of what we always started off with. Now to solve for the exponent, which log should I use to get rid of E? Natural log? Good job if you said that. I can't hear you, but let's say I heard you. Natural log to both sides? Natural log?
This be maestro que está uno de la esta.
Yeah.
El matemática.
Someone's speaking Spanish. Who's this?
Oh, my fault.
Oh, hey. How's it going? You doing okay?
Yeah, I'm fine.
All
How's
right.
your raccoons?
They're not caught yet. Let's say that. Oh, but I did find the latrine.
A what?
I looked over the edge of my roof and I saw literally probably like 3 pounds of poop. So it's been pooping off the side and it's been getting caught right next to the chimney of someone else's house. Yeah. And it's been raining. So hopefully there's no cracks because that poop is probably going to liquefy into their chimney. But that's for a different story.
I mean, that's something nice to wake up to.
Yeah, it's like, what was that movie where there's a haunted hotel? The Shining.
The Shining.
Sorry, F was our final value. And initial.
I is initial.
Right, so, yeah, it's like the Shining. Instead of blood raining down, you have poo coming down your chimney.
Ew.
So natural log of 1/2. As we talked about before, the whole reason why we do natural log is because that cancels out. Because they're inverses of each other. So we're left on the right side with 90R. Now on your calculator, go ahead and type this if you guys have it, just to practice. Do this here, first on your calculator, and then divide it by 90. I think that's a lot easier to do. You could rewrite it as natural log of 1/2 all divided by 90. But for a lot of you guys, to do that on a calculator could be a little confusing. So I think you should first do this here on your calculator, then divide, oh darn it, it's not divided. Then divide by 90. Try it. I'm going to do that right now with a calculator on the side. Which I don't know where to put my cell phone, which is my calculator. Oh, it's in the pocket. I got a decimal. You're supposed to. And that decimal is the rate of change. The rate of change. Looking at my emails right now about people. Did Emily ever get a chance to get on? Emily, yay. Okay, sorry, I got your email. I was trying to deal with my raccoons, and not only deal with my raccoons, I was trying to get back on here. Sorry. Did Crystal get that? Did Crystal get on? This is Crystal. Thank you. Crystal did get on. You guys can also raise your hand. Right? I think that's a feature. You can raise your hand, and that'll pop up on top, so I can see you guys. Okay, Jacob, you have a question? Or not? There you go. Hey. Okay, so if you guys have the answer, you guys can type it for me. We can all check at the same time. Make sure that you know how to use your calculator. So I'm getting R is equal to negative 0.007. Sorry, I got disconnected. I need to screen mirror again. Start broadcasting. Uh-oh. Is this working? No. Sorry. This just died on me for a second. Let me try again. It kicked me out of my room. Okay, we're back. Sorry about that. Okay. Did anyone else know you guys are out here still? Okay, so my rate is right here. Now, in percentage wise, this is negative 0.7%. So that's actually a very small rate. That's why it took you 90 whole years to drop in half. 90 whole years. That's a long time. $90 whole years. 90 whole years to drop in half. So now that we know the rate, we can now predict what would the value be in 270 years. So going back to our equation, we have n is equal to n naught e to the rt. We know our initial value is going to be 8,000. N is equal to 8,160. We know our rate of negative 0.0077, and our time is not 90 years anymore, but we can now use that rate to predict how much at 270. So here's the idea why we have to find this rate. Just because you know the half-life just means you know one instance of it. You know it will drop in half in 90 years. But how much will it drop if you had 80 years? How much would you have if you had 100 years? How much would you have if you had 1,000 years? You can constantly count by 90s if you want, but what about all the values in between? So in order to find all the values in between, we have to solve for this R value. That R value will let us find all the values in between, because that tells us our rate. So now that we have this magical rate number, we can plug it in a calculator, and that'll tell us How much after 270 years? Oh, we can do that. 160 times. So you guys can try plugging this in your calculator also.
See.
Need that number. I'm getting 1020.45. That's what I'm getting. Okay, so for this problem, you could have also done it a very cheesy way. And what I mean is that, isn't 270 just 90, and then 90 again, and then 90 again, 3 times? So if we started off with 8,160, and after 90 years, you would have ended up with 4,000. And wait, is that number right? Is that what you guys got? That value. Huh, that's the number not. Why is this number not seem like it's on the 80 if I do it again? It should have been 2040. Oh, and then after another 90 years, we're at 1020. Okay, how much will be left after? Try to say 1020, see what happens, what it says. Okay. Yeah, you could have, in this case, in our last problem, because 90 went into 270 so easily, if you look at what I did here, from the first 90 took it from 8,000 to 4,000. The second 90 years took me from 4,000 to 2,000. And the third 90 years took me from 2,000 to 1,000. And yeah, it could work nicely if it worked out to be a number divisible by your half-life time. But if you look at the next problem, if you want to go from 96 years, oh no, this one is actually divisible still. 96 goes into 480. This is 5 times actually. Let's see, but as the problems get harder, this one is 6 years still. This one is compounded annually. Okay, this is compound interest. This is about rats. They tell you the rate of population decline. So real quick here, the reason why our answer back here was not the same here is because of the round-off error. Remember this decimal kept on going, 0.07, sorry, 0077 ... That's how we ended up with this extra 0.45. Yeah, these are yesterday's IXL problems. Bobby was asking about them. So today, we're just going to work on going back to look at the graph with the domain and range. And I think that's pretty much it for this chapter. We might have to work on graphing it some more because we did kind of breeze through that. But when it comes to solving logs and rewriting logs, we've pretty much done all the work for it. like these low-level problems right here, you can actually just, which is not like the way you'll do it for harder problems. But let's say it says a town doubles in size every 55 years. If the population is 1870, what will the population be in 110 years? So if we start with 1870, after 55 years, we end up doubling with, sorry, too many numbers. 1870 would be 36, 37, 40. And then after another 55 years, we would end up at 67480. So for these problems, sure, you didn't have to practice all this stuff up here, but this is how you're supposed to do it for values that don't fall within the nice divisible values.
But how do you set it up if you're actually trying to figure out the answer?
Yeah, okay. So if it's a value, like the ones that they gave us previously are actually pretty easy because they're kind of divisible. If not, we set it up the way we traditionally did up on top, where we say, I know that the half-life model goes from 8,000 to 4,000. So we set it up and we first always initially look for our R rate, our R value here. Once we find the R value, we can then predict it at any time. And when we did our R model problem, we ended up with this answer down here in the middle. We ended up with this guy here. And that is really close to if we just started dividing by 2 3 times. And the reason why it's not exactly the same answer is because I didn't carry out enough decimals. And with exponentials, the more decimals, the better, because even a slight change in decimals, because exponential growth, it blooms up. So we can do this one here. Just real quick, we'll do it both ways and we'll see if we get a similar answer. So n naught, so n is equal to n naught e to the RT, where n is, let's see, how much of a radioactive kind of mercury will be left after 90 days if you start at 5,672 kilograms? Well, if I cut that in half, we end up with, what was that? 40, 28, 28, 36 equals to 5672 e to the R, and we said the half-life is 47 days. So it's always set up in this same model, where this is our start, initial, this is our finish value, and we're given some time period for that to happen in. And then we just solve it. This becomes 1/2 is equal to e to the R 47. We take the natural log of both sides. And then we divide this by that. And on your calculator, if you try it, it'll be 0.5 natural log divided by 47, which I'm getting a rate of negative 0.014747812. So n is equal to 5672 e to the negative 0.0147. I'm sure I care this says many decimals as I can, times not 47. We're trying to figure out the new date, 94 years later. So if I plug this into a calculator, times 5672, and I got n is equal to 1418. And it's because I carried so many decimal places, it actually gave me a whole number here. It's probably still rounding, but so after 94 years, we end up with this many grams. Now, that's just do it by hand. Let's just say I had 5,672 grams to start. After 47 days, we said we would have ended up with 2836. After another 47 days, we ended up with 1418, which is our answer. This answer and this answer are the same here. This easy way works, again, only if your interval period divides into a value that they want nicely. And that's 2 cycles. Anyone have any questions? Again, if you have any questions, you can also type it into the chat box. If not, I'm going to go on to the next one, in case there's any questions on Excel. Compound interest word problems. Were you guys okay with this? Would you need to convert any units, right? Only if they, for instance, switch from grams to kilograms or days to years. What happens is the time interval is taken as that time interval. These t's always work with whatever you start off with. Now, if this rate here, this r that we found for this last problem, last one we found the r was, let me find it. Our r was this number here. And that is not per year, that's per day. Because this time here was given in days. If this was given in years, this rate would be a rate per year. So it just depends on how they word the problem. If they give you years, but they give you a day rate, you have to convert that, yeah. Because those values are totally different. Good question though. Okay. Any other questions on this? The next question here, half of it's just fluff, like the bottom part's the fluff. The real part is Connor and that first paragraph on top. And I'm going to jump to the harder problems. Let's jump to level 68 problem. Ooh, smart score. Okay. 10 years ago, Harold won some money in the lottery and put it in the bank. That earned 10% interest compounded quarterly. If Harold currently has $100 in the bank account, how much interest would he earn? Why would they say that? He won the lottery and he put some money in the bank and he only put $100 in the bank. What do you spend the rest of his money on? Gosh. Okay. So this is a compound interest problem. Quarterly. The word quarterly means 4 times per year. And they give us a interest rate. If you look at the interest rate, it's 10%. Do you see how they say quarterly? Not yearly. And that's super important. It's quarterly, not yearly. So the actual equation we use is A is equal to P 1 plus R to the T. Why do we use this one and not the fancy one? P 1 plus R over N to the NT. Thank you, Giselle. Thank you, Giselle. Thank you, Giselle. Okay, let's look back at this question. How much interest did he earn? He holds $100. That's how much is in the bank account at the end. He won some money from the lottery and he put it in a bank account that earns 10% interest rate quarterly. 4 times 10. Harold won some money in the lottery and put it in a bank account that earned 10% interest rate quarterly. If he currently has $100 in the bank, how much interest has been earned? So let's go ahead and find the initial value. 100 divided by 1 plus 0.10 over 4 to the 40th power. Enter that on the calculator. Gosh, no problem rushing into this. 1 plus 0.1 divided by 4 close exponent 40 equals. So we start off with $37.24. We take, so his initial was $37.24 and his final was $100. How much interest did he earn? 100 minus 37.24 is equal to 62.76. Thank you, Giselle. Okay, sorry, that was a waste of like 10 minutes. Stupid Mr. Ko. I'll be posting this on YouTube so that everyone can see how I made a mistake here. If you want to go back to the video, oh, maybe I could edit this. Nah, forget it. I'll leave it in here. Any questions about this one? Yes, I got it now. I made a mistake. So the same idea for these other problems. They're asking you that I have $1,000 in the bank account after 5 years. How much did Anna earn doing odd jobs? How much money did she make? So, do you guys want me to do this problem? Or okay? Any takers? Okay, I'm going to go ahead and, oops, who wins this one? That's right, Giselle. Apparently, maybe that wasn't in US dollars. Maybe that was in like Chinese yuan or something in the communist country. So, there you go. Sucks. Maybe it was like their elementary school, like lottery. But what more is crazy is that their interest rate was like 10%. Who gets 10% interest rate? All right. So the only thing we're going to do is for this section, I'm going to go ahead and give you guys the domain and range. This one here. So I'll assign it. And these questions here aren't terribly difficult if you are okay with domain and ranges. What domain is? Domain is always your x values. And range is your y values. And the idea is domain is what you plug in, and range is what you get out. So the domain of this exponential function, if I'm looking at this graph, it goes like this, right? Does this graph keep on going forever in this direction? Does this graph keep on going forever in this direction? Is there any values I'm not allowed to use in this graph? Are there any points where I skip? Are there any holes? on the inverted asymptotes. And for exponential graphs, the example is y is equal to 3 to the x, in this case plus 4. Oh, this one's just shifted also. But in this case, here, is there any values I can't plug into x? All real numbers, you're right. So if it's all real, that's this guy here. Looking at this value here, what is the range? The range is your y values. Now looking at the graph, and the graph looks like this. Does it look like I'm gonna skip any y values as this goes to negative infinity, hell? This goes up to the heavens. Again, it doesn't look like it's gonna stop there. We're not skipping any values. So again, this is all real numbers. If you look at the way they write this, they write bracket. That's a terrible bracket. Bracket. Y bar y greater than -7. This means the y answers consist of these are the conditions. This one is specifically saying that what your y answers are only y that are greater than -7. The second one, the y answers are only when y is less than -7. The fourth one is y answers are only when y is greater than or equal to -7, and y answers are only greater than -7, or less than -7. In this case, if you look at our y values, they go from negative infinity to positive infinity. So being okay with that lingo, the verbiage, is something that we're just practicing here. Let's jump. I guess let's look at something a little more tricky. Looking at this problem here, what is the range of this logarithmic function? So now they didn't give you the graph, but can you spot what this graph will look like? A log graph looks like this. That is a general log graph. When we say log of x minus 9, we move this log graph down 9 spaces. But does this change this graph? Does it still not go to negative infinity? Does it still not eventually make it to positive infinity? Just because I move it down a couple spaces, just because I draw it like over here now, doesn't this still keep going? Doesn't this still keep going? So this is actually all real numbers. This exponential function. Are there any values that I can't plug in? Any values I can't plug in? So this is domain. Remember, domain is numbers I can plug in. So if I say 8 to the 0 power, I can do that. That's 1. Can I make the exponent negative? 8 to -1, I can do that. Can I make 8 to a positive number? Yeah, I can do that. So there aren't any numbers I can't plug in. What if I plug in x is -4? That's 8, -4 plus 4 is 8 to the 0. Well, that's a number. That's an answer. So it turns out, find the domain. I said it could be any x answer. Come on. So just practice this. This one is same type of idea. What was the domain? What are the domain and range of this log function? So again, the domain values are what values can I plug in, and what values, range is what values do I get out. So looking at this log function, y is equal to -6 log of x minus 2. we could graph that. Graphing that would probably be a lot easier if I had a graphing calculator for Desmos. But my question for you is, what values can I not log? Let me draw you the graph of a log just in general. This is a regular log graph. And it looks like this. Does anything happen here for a log? Can I take the log of 0? Is log of 0 even a thing? Can I plug in 0? So remember my circle of logs song? This is a common log. Common log to the exponent will give you 0. Is there any exponent of 10 that would ever give you 0? Is there any exponent of 10 that will ever give you -1? Is there any exponent of 10 that would ever give you a -10? Just through multiplication. Let me write this in a different way. Is this possible? 10 to the blank power is equal to 0. 10 to the blank power is equal to -1. 10 to the blank power is equal to -10. And there's nothing. That's why this graph here is always left intentionally blank. There is nothing over here. So log can't be 0 and log can't be any negative value for us. So in our problem here, can I plug in 0? No. Can I plug in -1? No. Can I plug in any negative number at all? Nope. So if we look at our answers, it says the domain is greater than 10. No, we know that's not true already. The domain is greater than 0. Yeah. The domain is greater than 0 for the third possibility. Yeah. The fourth answer, all real numbers, we know that's not true. So for sure, if I say A, B, C, and D, both A and D are not options already. Looking at the range, we can go from -infinity to positive infinity. That's not a problem. This graph isn't just bounded. Look at your option C, the third possibility. If you look at the third possibility here, they say y can only be greater than 0. If you look at my graph here, that's not true. I could have negative logs. Okay, they're right. The answer is B. Good job. The answer is B, because first, our answer has to be greater than 0, and we can have any y value. Brilliant. I know. Just kidding. Okay, last one is as an example. It's state the domain and range. Y is equal to e to the x plus 8 plus 1. I feel like domain and range is really, well, you guys are all concentrating really hard. That's why, Giselle, just like in class. Evan, Giselle. I was gonna do a Kahoot, but then I ran out of time because he's stupid raccoon. I'm actually supposed to be in a meeting with the administrators right now, but yeah. Okay, so let me see. Are there any values for x where I'm not allowed to use? Right? If you think 3 to the x power, is there any value you can plug in here? If I plug in a -1, if I plug in a 0, if I plug in +1, right? 3 to the -1 is 1/3. That's an okay answer. I don't like it, but it's okay. 3 to the 0 is 1. Hey, that's okay. And 3 to the 1 is 3. So there's no values I can't plug in. So for exponential values, your domain is always all real numbers. And just to graph this, to talk about it, an E graph looks like that. There is no x value I'm not allowed to plug in. See, we can go to -infinity and positive infinity. Our y values, though, that's a different story. Our y values are bounded. So if you remember what each of these characteristics do to the graph, this value here, let me pick the right color, this exponent shifts it from left to right. Left to right. What value would make me reset that exponent? if x was negative 8, perhaps, wouldn't that give me e to the 0? And e to the 0 is 1. And that's how we reset the graph. That's how we end up with e to the 0 right here. That's my 1 value. That's what the value I think you should always aim for. Try to make that go to 0. So this graph, if I really wanted to graph it, would have been 8 spaces to the left. 1, 2, 3, 4, 5. Let's just call this negative 8, right? Time by 2's. And when x is negative 8, when I plug it in, that would be 0. And 0 plus 1 would be 2. And we had drawn these horizontal asymptotes before. The graph would look like that. Oop, I missed it. And that's my 1 value. We moved from initially here and moved back space 8 spaces and up 1 space. And you can see, if I can write it again, we went e to the x plus 8 plus 1. We went back. Darn, that looks terrible. We went back negative 8 spaces and up 1 space, which make these graphs kind of easy to read. Thanks, Evan. If I give you another one, just make it up. If say y is equal to e to the negative x minus 2 plus 3. So to make this go to 0, it's a plus 2. So we move the graph 2 spaces to the right. And we add 3 means the graph goes up by plus 3 spaces. So the easiest point in exponential is always this 0 value. If x e to the 0 is 1, we can move all those values over to the right 2 spaces and up 3. That's my new dot. Yep. And this is very similar when you guys graph parabolas. So what is my domain? We said we can go all the way left, all the way right. Exponentials are great that way, all the way left, all the way right. But our y values, we don't even get to start until not 3, in this case. Sorry, going back to the last question. We moved up 1, so it's not 2, right? We moved, this value is now 2, because it's up from 1. It's actually 1, from 0 to 1, from 0 to 1, from 0 to 1, from 0 to 1. So we go from 1 to infinity and beyond. Yay. Oh no, what'd I do? Ah, I wasn't paying attention. If you look at the answers, they are slightly, ever so slightly different. Ever so slightly different. If you look at it, one has a bracket and one doesn't have a bracket. And of course, I wasn't paying attention. Am I allowed to touch the dotted line? Will we ever actually hit the dotted line? Remember, it's like an asymptote. So we're not going to hit this asymptote. So it turns out the answer was the non-bracketed one. The non-bracketed one. Okay, glad we can learn from our mistakes. So I'll give you guys this. I think this might be the only one I might give you guys today. I guess we can practice some other easy ones here too if you want. Any other questions or concerns? Again, the 10-week grades have been pushed out to the first Friday of April. We won't start school at least to after spring break. I think the governor or we're on stay-at-home lockdown to like the 18th or something. You guys look that up on the news. So, okay, We'll do this again on Tuesday. I'm gonna do it every A and B day. Sorry again, I was supposed to start at 10 today, but we started off really late. It's because of the raccoon thing. The peanut butter traps set around my complex right now, so I have to check them every day. Besides that, thank you for showing up. Sorry about the late delay. Real quick, can you guys, darn raccoons, that's right. Quick response, can you guys respond in the text box here? How did you guys hear of this? Was it through Schoology? Was it through the email that I sent, or from both? If you guys haven't signed up for the response online, you guys can still do that. Let me get the link. If you guys haven't given me your email, you guys can go here and give me your email, and then I can send you a direct email in case Schoology is slow or down. The first day, Monday, Tuesday, I think Schoology had like a 10-hour delay, anywhere from 2 to 10-hour delay. So if you guys haven't signed up for that email, go ahead and click that link. Don't forget to like and subscribe, ring the bell. Just kidding. It's going to be both at the same time. Hopefully, Schoology is not sending these messages like 10 hours later. Like one, I was live streaming like at 11, but it didn't send out the notification to 11 at night. So kids are like, "Hey, where are you, Mr. Go?" Yeah, I'm gonna make my own YouTube plaque out of like wood. I'll make it out of chalk, right? I'll reconstitute the chalk, put some glue in it, and then make my own play button. It's hilarious. Okay. Well, anyways, I'll post this on YouTube so you guys can have it also. Okay.